Now SIMBA is compatible with all the ML and artificial intelligence library that exists out there. And users start to use those machine learning algorithms to optimize their design, basically.
Welcome to another ipXperience interview with Guy. So I found out about SIMBA because I connected with Arn through just chatting to engineers through ipXchange. This is a very interesting simulation tool for power electronics and motor control. Enjoy.
Welcome, Emmanuel, to the world famous ipXchange studios.
I can recognize the background.
Where we look at and interrogate disruptive technology. That's what we're looking for. How our community of over 6,000 design engineers around the globe can help solve problems in alternative ways. So today we're talking about simulation, which in electronics can actually mean many, many, many things. And I'm not going to even begin to understand what this variety of simulation is all about. But luckily, we have Emmanuel on the call, who's going to tell us all about it. So first of all, Emmanuel, tell us about what your business does, its name, and how it helps solve design engineers' problems.
Sure. So my name is Emmanuel. I'm from Canada. Thanks again, Guy, for the invitation. And I'm developing a new power electronic simulation tool called SIMBA. You can check it out on simba.io. So very, very quickly, SIMBA is a power electronics simulation tool. So in the electronics world, there is a category of devices that we call power electronic converter. That's basically electronics, but that can handle high current and high voltage. The goal of the power electronics converter is to transform electricity somehow. And we are developing a tool that is, I hope, useful for engineers to design better power converters.
Right. So how would you solve if you didn't have your software and you were trying to solve this high current problem? How would you be doing it today if you didn't have the simulation software that you have?
So first, we have not invented simulation software for power electronics. Simulation software for power electronics existed for like the last 20 years. And so the first question is, why do we need simulation to design power converters? So the goal of a power electronics engineer is to come out with a design, maybe with a PCB, with components that are selected, and the overall converter, we want it to be very efficient, we want it to be safe, and we want it to match the requirements that were set in terms of voltage, currents, power, weight, cost. So we use simulation to select the type of converter that we use. In the power electronics world, there are a lot of different topologies with different configurations, and we can check which configuration, which topology will work better than other. Then once we have selected the topology, then we go into component selection, and we can look at simulation. We model the different components, we enter them in the software, and we will run simulation, and we'll be able to compare the behavior of the converter with different converters, with different components in terms of losses, efficiencies, again, requirements, everything. And so we will use simulation software to select and design components. That's probably the two main reasons why we'll use simulation.
So let's just clarify that. Let's just clarify that, because you're not using it to design the component itself. You're using it to compare and have comparison of taking people's semiconductor manufacturers, where they're laid out and how they would work efficiently together before you actually put them on the board.
That's right, exactly. And so the simulation will help the engineer to come out with a design. Of course, we always need prototype, because simulation has its own limits. There is no such thing as, we cannot simulate reality. We need to make assumption. So of course we need prototype, but in the entire design space of converters, simulation will help to kind of restrain the list of designs to find the best match. So this is what power electronics simulation is about. Then what's the value of SIMBA over the other tool, and why we think it's I don't know if we can say it's a disruptive technology, but yes, it changes. It can change how a converter are being designed. So
but we don't have to
Mhm.
use disruptive as in, you know, if it's disruptive, if it's bringing a new way of doing something, or if it
yeah,
speeds something up, or if it makes something efficient, you know, doesn't have to be a
yeah,
complete
it's
change of direction.
I think it's the case. So usually, traditionally, you power electronics engineer will go to their software and build a model manually and select the component and enter them in the software and click a button to run a simulation, and then look at waveforms and and decide, okay, the efficiency of my converter is 90%. Maybe I will go back, change this value, or I will use this MOSFET instead of this MOSFET, and we'll look at the result. So that's kind of the traditional way, where the design workflow is basically start with the requirement, and then you have a mix of simulation plus Excel plus the experience of the engineer. In SIMBA, first with SIMBA you can repeat the same approach. The just simulation capabilities of SIMBA are very good. So simulation will be either more accurate, or the results will be calculated faster. But the best thing with SIMBA is we are shipping a Python library with SIMBA. So what is Python? It's basically a computing scripting language, okay, that you can use to uh, um, to run to call SIMBA and to call the simulator from a programming language. And this sounds not really crazy, but it's super helpful. So because as I said, the goal of the product mix engineer and the goal of simulation is to find the best possible design in the entire design
Yeah.
space that exists.
Yeah.
And with
So can I just
SIMBA,
pause you for a moment?
yeah,
Can I just pause you
yeah,
for a
please,
moment?
of course.
I understand the concept.
Mhm.
Utterly understand the concept. So are you reliant on all the manufacturers' data of all their components? So so how many manufacturers, for instance, data do you have in your libraries?
Yeah, so that's a good point. Um, in SIMBA, so we don't have manufacturer model or component directly inside SIMBA. So you have to create models. But
You must be
most of the
reliant on but you must be reliant on their data. You must be reliant.
exactly.
Okay.
Yeah. Most of the manufacturers provide actually models in standard format that we can import, that we can use inside SIMBA. This is more for semiconductors, actually. That's actually when we do power electronics, the most critical part is the semiconductor, and we need super accurate model of diode, MOSFET, and IGBTs. For the rest, it's kind of the other model, the approximation that we make are usually sufficient. Have I answered your question?
I'm not sure you have. No, I think that
Uh-huh.
you have a layout and you're doing conversion, and you've probably got a combination of maybe how many on the average system that you're looking at. How many parts will there be?
From 20 to 100, something like that.
20 to 100. So you must have, I don't know, 300 manufacturers that can potentially supply those solutions.
Yes, but it's not like a SPICE tool where you need or like a CAD tool where you need to have all the part of all the manufacturer, because you need to know the size and the package. No, here we're interested in the electrical signal. So a
Yes,
resistor.
I understand that,
Mhm.
no, I understand that bit, but you still must be reliant on their data that says they are efficient in this way, they use power in that way.
Yeah,
You must
that's true. Yeah, that's true for the semiconductors. And for the for the rest, it's okay. But for the semiconductors, we need to have super accurate model, and we need the data from the semiconductor and from the manufacturer. And there are different ways we can use a model that they provide, or a user can create the models themselves, but based on the data sheet.
Okay, all right. So they run the simulation on your software.
Yeah.
If are they? So two questions for you. Do you give the simulation on what they have laid out, and then do you offer alternatives that your software simulation you think will offer a better solution, or do
That's a
you?
good.
Or the third question, maybe we should just have one question at a time. But the third question is, once it's, will it then offer an alternative?
Yeah, that's a good question. So first, the output of the simulation are waveforms, and we don't automatically offer alternatives. Also, however, and that's the beauty of SIMBA, is with SIMBA you can automate calculation and you can also optimize your design. So instead of running one simulation from one corresponding to one design, you can simulate 100, 1,000, 10,000 different designs that are virtually built in the software to find actually the best design to optimize the converter.
Right.
And
so okay, everybody's system is different. Everybody's application is different. So everybody will have started in a different place because their application is different.
Yep. Exactly.
Yeah. So they will have their layout using their components. I'm still trying to understand what your simulation software then. They've done their layout. They've got their application with their input and then their output, and you're trying to understand the efficiency of that conversion. What if that is the case? What is your simulation actually doing? Just explain to me what it's actually doing just let's keep it simple. Just what is it doing at that point? Because if they've laid something out, they understand what their application is and they understand what they want their output to be. So they're if you like to keep it simple, they have a beginning, a middle, and an end. Where's the benefit of using your simulation?
Actually, it can be everywhere. First, it can be set to get an initial design. Okay, so you use SIMBA, you say, okay, maybe I will use this semiconductor from that manufacturer, and I will use that topology, and I know my input voltage will be, this amount, and the output voltage will be 40 volts or 80 volts. And then the engineer can come up with an initial design. Then you can use SIMBA to optimize the design. Say, okay, but maybe I want to compare 20 semiconductors from different manufacturers and look for every simulation at the junction temperature. Look at what happened when there is a voltage variation on the input or on the output.
So comparison at that point is very useful.
Exactly.
Okay, so I understand now. So I think that was I lost where I was with the number of questions.
I was probably not clear.
But I think that was my second question, which is you will then, so you have your layout, you know what you're trying to achieve with your power, and then you can then, if you like, just take one component out, put another component, and see what the difference is when you do that.
Yeah, and you can do multiple components as well, and that's something that is kind of new. And because of this Python library that we're shipping with SIMBA, now SIMBA is compatible with all the ML and artificial intelligence library that exists out there. And users start to use those machine learning algorithms to optimize their design, basically, or to build algorithm or to validate algorithms that are used for multiple shows and multiple things. And this is something that is kind of new in this industry. And when we have designed SIMBA, we have that idea in mind in having a super fast, super accurate solver that is compatible with the workflows that are based on machine learning algorithm to come up with even better designs.
In some of those markets that you've just described, the world is changing nearly every week. Nearly every week, you'll hardly ever see something in machine learning and artificial intelligence where something isn't changing. So how do you keep your libraries fresh and up to date? Or do you just say, we are 3 months up to date, or we are 6 months up to date, or you just give a list of manufacturers that you can compare and contrast? Is that what you do? How does that work? How does an engineer know? How does an engineer know? I know this is a difficult question for you because you may not have a perfect ultimate answer, but do you list all the things that you compare against and then say, we will keep that updated as we go along? How does that work?
Yeah, so the only thing that we do is we are not developing the machine learning library ourselves. We just make sure that SIMBA is compatible with everything that exists on the market.
Yes, that's what I'm saying.
So we don't have to maintain everything. We just make sure that SIMBA is compatible with everything that is out there, and that's it. Then the engineers themselves can be like power electronics engineer / data analysis. So it's funny that people that have no background in power electronics starts to use those simulation, but it's the case. And they can use simulation to train machine learning models. And this is something new that really didn't exist like I don't know 10 years ago. And yeah, that's about it. Have I answered your question?
No, I think you have. I think you have. So if we just recap now, we're interested in power electronics simulation. We're interested in bringing the power in, doing the conversion. You're able to offer your simulation will show how, if you had this layout, how efficient it would be, and then you can then take alternate parts from a library, interchange them, and then see whether or not that would be more efficient than the initial layout would be, and then you can compare and contrast your layout from that. Have I summarized that relatively?
That's
relatively
better
well?
than that.
Okay, good. Right, my last question. Huge market. Where do you see your sweet spots? If you're dealing with a multinational company that's employing thousands of design engineers working in power electronics, I instinctively believe they may not turn to you, but maybe you've got an alternative answer to that. So what is your sweet spot for a company with where they are, not geographically, but where they are in terms of application, and where, what would be your perfect customer? If you get inquiries come in and you go, that's not going to quite work for them, that's not going to be perfect for them. However, they ring in. Not that anybody rings anybody anymore, but if they did, if somebody on the phone did ring and you went, I've got the perfect customer, what would be the profile of that perfect customer?
So first you can use SIMBA wherever for every power converters you can use SIMBA to design it, and you have power converters everywhere in your laptop, in a wind turbine, in electric car, in a drone. You have power electronics everywhere.
Yeah.
For some reason that I think are kind of clear, like probably, I don't know, 70, 75, 80% of our users are in the automotive industry designing electric cars. This is
right.
The main reason it's where the investment that consists in spending a lot of engineering time optimizing the design to the corner, make sure that the car will last at least 200,000 miles. That's basically the market that SIMBA is big.
So when you say electrical cars, do you mean electrical vehicles as not just cars, but anything that is?
Yeah, you're right. Yeah, right. Electric vehicles. But like most of our users are somehow related with electric cars, like 60-70%, but it can be used also in all electrical vehicles.
Okay. Last question. How does, if one of our community says, I think this whole idea of power conversion simulation is for me, how do they're going to come to ipXchange.tech for a start? That's where they're going to come. That's where they're going to come first.
Okay.
Here first. Yeah. You're going to go to ipXchange to find out how you evaluate SIMBA. But what do you get when you evaluate it? What do you get? You come to us, because that's where you're going to come. You come to us and say, I want to evaluate SIMBA. What do you get to do that?
So first, we always like to start with a discussion with our engineers to understand what are the challenges and see, in a 10-minute discussion, we can understand, if it can be a match or not. And if the person want to evaluate, SIMBA can get a free license for the period of time, can be 2 weeks, 1 month,
Oh, right, okay.
more if required. And during this evaluation, our engineers will assist them in order to make sure that at least they understand how the software works and how it can be useful, and then they can make like a decision out of it.
Very good, very good. Well, Emmanuel, I started this discussion knowing absolutely nothing about power conversion simulation. With your great wisdom and knowledge, I think that I probably know a little bit more, but our very clever engineers in our community know a lot more, because you've been very informative, and I think we understand, well, we certainly understand enough that if we're trying to look to do power conversion, we want to be able to simulate something, we want to be able to compare parts, we want to be able to see efficiency, and we want to do that particularly if we're working in electrical vehicles. Then we should come to ipXchange.tech, and then they will be able to have a conversation with you and see whether you can help them make more efficient systems. Emmanuel, thank you very much.
Thank you so much, Guy. That was nice chatting with you.
So I'm not sure if you felt it, but Guy definitely gave Emmanuel a bit of a grilling to do with the library for SIMBA. But all's good. Looks like a great solution. If you want to try out this simulation tool for your own power design applications, apply on ipXchange.